Hey everyone. Now I wanted to share with you a situation that's happened with my ISP provided internet here lately. So what's happened is I was just doing my thing as I did, and the internet was down. Now that happens from time to time and usually comes back up, but I've got a backup for that for when that happens anyway, which I'll show you in a bit. But anyway, the internet went down and I didn't think too much of it. I let them know. I said, hey, the net's down, and it eventually came back up. But while it was down, I did a little bit of a packet capture. So I'll show you what I saw. All right, so this was taken on my router, which is a Raspberry Pi, on the interface which is connected to my modem and it goes out the phone line. So as you can see, what I'm doing here, it uses PPP, point-to-point protocol, which I wish they didn't, but it does. So what's happening here is the PPP daemon on the Raspberry Pi is looking for a PPP access concentrator. So you can see it's just sending a broadcast out every bunch of seconds, and it's a bit random. Then I had to restart it and see what's going on. And you can see there's no response from anything. It's just the Raspberry Pi looking for stuff. So that was what I first saw. Then a little while later, the internet was still down, but I did another capture just to see what was happening then. And this is what I saw that time. So this is what I saw then. As before, I send the initiation as always, and I got two responses here. You can see the MAC addresses are different from two access concentrators, both called wireline. And then there's a bit of back and forth, blah, blah, blah. My username goes out, which that isn't what it really is. I've just modified it for this video for you lot. But I got a successful authentication, beautiful. But then immediately from them, I got a termination. So it didn't go anywhere. It got further than before in that it found an access concentrator. But as you can see, even though it authenticated, it just sent a rejection to me. So I don't know what that was about. So that was the next thing that happened. Then finally, later on, the internet came up. And I thought, okay, the net's up. Obviously, they fixed it up and it's flowing. But what happened was my IP address was different. And that hasn't changed in the years that I've been using them. So I thought, okay, what's going on here? I didn't think too much of it. In fact, I didn't know the IP address had changed until I tried to log into some sites in Australia. And they thought I was overseas. So that's asking for extra authentication and SMS to confirm it's really me, because they thought it was something from some other country. So here's what I saw. Okay, so this is my router. And if I have a look at the links I've got here, I've got a lot of VLANs on here. But what I've got is VLAN 2 goes to my modem. And I'll show you in the garage how I've got this set up. Okay, so in the garage here, I've got my equipment. I've got the modem here, the switch here, wireless controller here, and the router behind it. So they're all separate devices, whereas a normal home user might just have an all-in-one device for the modem, router, switch, and all that. But anyway, I'll show you how I've got this set up. Okay, starting off on the patch panel here, I've got the phone line which comes in from the street, and it comes out of this port here. That then goes into my modem, which is this SFP modem here on the switch. Now that port on the switch I've assigned to just an access port for VLAN 2. So my WAN VLAN on this switch is VLAN 2. Okay, so behind the switch, I've got this Raspberry Pi here, which is the router. Now, it's only got the one physical network interface, but what I've done is just tagged it as VLAN 2, and that goes through the switch's VLAN 2 and up to that modem. So that's effectively my WAN interface on the router. I've also got this 4G adapter here for mobile internet. Now that shows up as another adapter on the Raspberry Pi as well. And here I've just got an external antenna connected up to give it better reception. So you can see that's online now. That's ready to go as my backup. And here it is on the side, the antenna for that mobile connection. It's not fantastic, but it is a backup that I can use when the main link goes down. And just in case you're wondering, yes, I did custom make every cable there to be perfect length to make it all nice and pretty, because I like my cables to be neat. Okay, so back in here, I'll show you the IP addresses. So if I go IP address, and I'll just trim it down a bit to show the important stuff. You can see here I've got all the interfaces with their VLANs. Wherever there's a dot like this is a VLAN, so that's VLAN 50, VLAN 80, and their corresponding IP addresses. The untagged one is just my normal LAN network here on VLAN 1. And this is the one that goes to the modem, that VLAN 2. And as you can see, there's no IP4 address here, okay, because it doesn't need one. But that sends that PPP traffic down, which is what I captured. So all this stuff here that I'm showing you, I did by capturing ETH02 and just everything that goes through it. So that way I can see the PPP traffic that's going out into the net. And when the link does come up, I get this extra PPP0 interface, which is my actual external address. Now, I'll have a look at this address. This is my IP address, but of course that's going to change whenever I restart that PPP connection, because the ISP have now told me that it's dynamic when it used to be static. But I'll get to that in a minute too. So anyway, that's my IP address. Now, if I have a look at that IP address in the RIPE database, you can see that it is showing as country AU. Okay, and there's my ISP, which is mate. It used to be barefoot, but now it's mate. Anyway, and you can see the range here. Now that range is, well, that would be 8,092, so minus a couple for the broadcaster network, 8,190 hosts. Okay, so that's how many hosts they can do with that. If we have a look though, what I decided to do was just pick an address that's just outside of that, like 32 dot, I don't know, whatever, and have a look at that. And when I look that one up, you can see it's the same guy's name, but its location is the US. And you can see the range that they've got here is a 16-bit network. So the one that my ISP is using is a portion of that bigger one from the US. So they've reused what this would have been part of the US, and in a lot of databases that isn't this official one, they'll still be showing as US. And that's why I'm having some problems with things like the Google login, and also because the ISP sent an email out that other customers are complaining about Netflix and things like this, which I don't use, but I guess they work on your location as well. So the IP itself, location's meaningless. It's just what it's in a database. Like one IP address can be in one country, the very next one can be in a different one. It depends where it's actually registered on here. So if I go to mylocation.org, this is what happens. It thinks I'm in America, but I'm not in America. I'm in Australia. So anyway, that's creating a bit of a problem for me and others. So how I can get around this at the moment is I have a VPN to a few people around town here, and one of them, I have a Raspberry Pi at his location, and he uses not this ISP. So what I've done is I've just got a proxy server on the Raspberry Pi over there. So if I need to go to something in Australia, I can go via that proxy. So on Firefox, I've just got this Foxy proxy here. And if I just go via Scott, which is him, and I do that again, you watch what happens this time. Now, it says I'm in Australia. And that'll be his ISP. And that makes sense. That's about where he is. So I can use that for sites that I need to be in Australia. But I guess not everyone has that capability, I suppose. So that's what's happening, and I can't really do anything from the ISP side because that's up to them. But something else that's bothered me is they did this change without letting me know that they were even going to do a change. They didn't say there was going to be an outage for an upgrade, because you could prepare for that, at least have it in mind. So when it went down, you go, they're working on that thing, and you might let it go. But they didn't do that. And they actually sent out some communications afterwards. I mean, I've put in a case, and I guess a lot of others did. And I'll show you what they sent. So this is what they sent out, and that scrolly thing is so annoying at the top. But here's what happened. Why didn't they notify customers about the change? Unfortunately, there were legal constraints on us advising customers earlier. There's no reference to what legal constraints they might be. And I find that very distasteful, because if you're working networking and you've got an outage, you let your stakeholders know that there's an outage, and you plan the outage, and you let them know of the planned time. That's how you do an outage. Another thing too is, because this isn't working, they've had to send out this communication here to try and simmer everyone down, because a lot of people will be complaining. It seems they didn't have a rollback plan. So why haven't they rolled back while they figured it out? And another thing is, it's not working. They should have tried this first. They should have staged this in an area, got these new IP addresses, made sure everything was fine for customers before rolling it out. So there's a few things they didn't do. They didn't notify customers there was going to be an outage. They didn't have a rollback plan, and they didn't stage it properly. Otherwise, they would have found this before rolling it out. So that's not good practice in my mind. But here's another thing. In here it says our new network that they've upgraded to gives dynamic IP addresses now, as opposed to the static one that I had before. Now, because I have an open VPN server here, I need to connect to my network from anywhere when I'm out and about. So my DNS entry, I'll now have to update every time my IP address changes. Now, I can automate that, but it's still a pain. I don't really want to have to do that. So anyway, as they say here, we understand that for a small number of customers, like me, A static IP address may be why you chose mate over blah, blah, blah. If you require a static IP address for your connection, let us know and we'll have it applied for you. Okay, I'm still with them working through this. I said, okay, I'll just do that. Here's what they responded with. Due to the legislation changes made by Australian Government and ACMA, all telecommunications providers are required to use multi-factor identity authentication processes for high-risk transactions from a couple of months ago. Okay, here we go. This is to ensure the person requesting the transaction is really them and blah, blah, blah. Before processing to give me a static IP address, before processing and confirming your request, we must verify over the phone or via chat these things. We will confirm at least 3 forms of identification. We will send a verification code to you via email or SMS for you to confirm. So they want to confirm my ID through email, even though they won't accept my request through email. And obviously they want some sort of other ID, which I don't like. But here's the problem. They want me to jump through hoops to get back a service that I originally had that they broke. That's fundamentally a dumb concept, okay? So they want me to spend my time and my effort and go through all this bullshit just to get back the service that I had before they fucked it. So that was the final straw for me. But while I did ask for the static IP address, I asked them if they got any plans to put IPv6 in now that they've done this upgrade. And they said no. They just flat out have no desire to do anything with IPv6, even though we're in the down end of 2022. Okay, I've dug out an old capture from a couple of years ago when I was looking at something. And another thing I noticed is they used to use these Cisco devices, whereas they don't anymore. And given that the Intel Corporation one they've got now tend to make hardware for servers, it kind of makes me wonder if they've gone to VMs, but I don't know. But either way, they've moved away from this, but you can see the old one was here. But something I wanted to show you was, where is it? In the request for config, you can see that I did a request for IPv6 and you get the configuration protocol reject for IPv6. So they really don't want to do IPv6, even though my router's trying. So given that they want me to do this crap just to get the original service back, that's pretty much the final straw for me. So now I'm going to look for another ISP. And if you know any out there in Australia that just give you an IP address that's static, preferably without doing the PPP stuff, because that's a bit archaic as well. I know one person out there who watches these, he said he just plugs his straight into his connection. He doesn't have to do any PPP or any auth. He just gets a DHCP address, which is static, and he just goes. So he doesn't have to do any of the PPP config like I had to do. But that's okay, I can do that. But if I don't have to, it would be easier. So if you know of any ISPs that just have some sort of unlimited plan at a reasonable price that is very simple and has IPv6 and a static IP address for IPv4, let me know. And for the others, if you're into networking, like I'm a network engineer, obviously, and if you're doing an outage, there's things that you've got to do. You've got to have a rollback plan. You've got to test the thing out first properly. You've got to stage it. You don't want to be, as a company, having a whole lot of angry customers writing to say the network's down because you didn't test it properly. They may go elsewhere, which is what I'm going to have to do. So anyway, I just thought I'd share that with you just to show you what goes on out there. And hopefully people will pick up their act a bit. Anyway, that's all from me. Till next time, take it easy.